This video tutorial will help you with section 3.2, pages 105 to 107, particularly problems 13 and 19 of your textbook. We're going to talk about sample variance and sample standard deviations. Sample standard deviations and the variance are used to describe the spread of data about the mean. The sample mean in this case is X bar, and it compares each data value and how close they are to the mean. I'm going to show you how to calculate these two measurements the old-fashioned way, since you have to demonstrate them in your mastery assignment. And then I will show you how to use Excel to calculate them. It is also a great way to double-check your work when you use Excel. So, if you would, we're going to go to page 96, and I'm going to go over example 6. And when you look on that page, you're going to also see that there is a table with 3 columns. When we do ours, it will have 4 columns because I'm going to compile the computation formula with the defining formula, and the only difference is you need to have a 4th column. So let's read this. It says, Big Blossom Greenhouse was commissioned to develop an extra large rose for the Rose Parade. A random sample of blossoms from hybrid A bushes yielded the following diameters in inches for mature peak blossoms. These are found right here, 2, 3, 3, 8, 10, and 10. We are going to use both formulas, defining and computation, to find the sample variance and standard deviation. The defining formulas and the computation formulas are here just so you could see that we are going to set up a column in a spreadsheet to fill in all this mumbo jumbo here with the X and then the X bar and the N. And that way, if you've got it all put together in a spreadsheet or a table, then it's so much easier to calculate. So here's what we're going to do. In your book, it shows just the first column being your X values. These are your data. And then it skips over to X minus X bar being your mean. And then in parentheses, X minus X bar, the answer to this column right here, squaring it. I added the X squared to be able to do the computation formula, which is right here, as you can see. So here's our data, our X values, 2, 3, 3, 8, 10, and 10. Then the second column says X squared. So you take the 2 and square it, and you get 4. You take the 3, square it, you get 9. You take the 8, 64, and 10 to 100. Becomes 100. Now, we are going to follow this information here where it says X minus X bar. Well, X bar is the mean, which means you got to go and figure out the mean. Well, the mean is simply down here. The mean is the sum of your X values divided by N being the total number. In this case, it's 36 divided by 6, and so our mean is 6. So as you see here, this is what we're going to do. So 2 minus 6 equals a negative 4, and then you come over here, and you're going to square that answer, negative 4. So negative 4 squared is 16. Notice that if you've done your calculations correctly, you should never have a negative value because you're squaring it. Then the next one is 3 minus 6. Remember, 6 is going to be our mean, and then I get these answers. So negative 3 squared is 9. Negative 3 squared again is 9. Then 8 minus 6 is 2. 2 squared is 4. Then 10, right here, 10 minus 6, the mean, equals 4. Then 4 squared is 16. And then the same thing goes here. All right. Now, you see the sigmas in our formulas. The sigma means the sum of. So I went ahead, and this is what you do on your, when you turn this in, you can write this on a piece of paper and scan it, or take a screenshot of it or with your camera and just send it. But when you add these values up, all the x's, the sum of x equals 36. The sum of x squared is 286. And then you skip over here, and you just add the 16, the 9, the 9, the 4, the 16, and 16, and the sum of this is 70. This right here, the sum of, and in parentheses, x minus x bar, close parentheses, squared, is this right here. It's this numerator for the variance. Okay, now the difference between a sample variance and a standard deviation is that the sample standard deviation is simply the square root of your sample variance. Now, so that's how you're going to calculate. I think the first one we're going to do is the defining formulas. So here's all the information you need to have. And I'm scrolling down to show you I've got it already set up. We're going to do the defining formulas first. And as you can see, it is the sum of x minus x bar squared. And when you see that, that right there is 70. So I put 70 here. N minus 1. N is the total number of data, which is 6. So 6 minus 1, and you get 5. So 70 divided by 5 is 14. So the variance, the sample variance for this problem is 14. To calculate the standard deviation, which is right here, all you're going to do is take the square root. So the square root of 14 is approximately 3.74. That's for the defining formulas. Now let's talk about the computation formulas. Okay, when you see something like this, let's just look at the sample variance. It's still going to be the exact same answers, but if you need to learn how to calculate these problems by the old-fashioned way. So let's just do the sample variance. That says here the sum of x squared minus the sum of x's that you will square and divide that by n. This right here, the sum of x in parentheses squared divided by n is right here. You need to calculate that first. Once you calculate that first, then you can plug it into the rest of the formula. Because the sum of x squared is 286, as you see right here down at the bottom of this table. So that's 286 minus 216, and that's where we got this. That's this right here, this portion of the numerator. And then divided by n minus 1. N minus 1 is 6 minus 1, which is 5. And then you do the math. Again, you're going to get 14. And then the same thing goes here. The standard deviation, the sample standard deviation is simply the square root of your variance. And that's how you do that. Now, these are sample statistics. The difference between calculating the sample variance and sample standard deviation versus the actual population standard deviation and population variance is that you do not subtract n minus 1. It'll just be n. So instead of it being divided by 5, it would be divided by 6. And that's the difference. All right. Now that's doing it the old-fashioned way. Now let's go and calculate these things, the same exact problems, but we're going to use Excel. First of all, I've already got the numbers ready. I typed in the word sum, mean, variance, and standard deviation. So we want to calculate the sum. So I'm going to click on E7, column E, row 7, and whenever you click on the equal sign, that starts a formula. Now I can go up here as well to this formula bar and choose the sum, okay? And then hit enter. Now it says E1 to E6, and that's what I want, so I can just go ahead and hit enter, which is 36. We already know this because we've already done this. Now, the mean. The mean is the average, and you see it's still popped up, so I'm just going to go ahead and use it. I've clicked on cell E8, which is where I want my mean to be, and I'm going to go ahead and click on the average. And it shows E1 to E7. Just go back up here and just go E1 to E6, and then hit enter. There you go. We already know the mean is 6. Variance. The variance in this case is going to be the sample. And as you can see, I've got my box opened up. I have var dot s is your variance, sample variance. Now, you see it hasn't chosen what I want to calculate. You see the parentheses here, and you see my the little dotted blue box. This is where you can just drag and to where you want it, and then just hit enter. Okay, we already know the variance is 14 because we calculated. Standard deviation, we want the sample standard deviation, and as you see the formula box, it's right here. Double click, and you're going to do the same thing. You're going to go to E1 down to E6 and hit enter, and there it is. And that's how you would do this. on Excel, and you have some homework problems that require you to calculate that, but I wanted to go ahead and show you the problem that we did in the book. Okay, and that's all you have to do. Thank you.